Okay, let's divide by 25 divided by 2 is 12 and remainder is 1. Then 12 divided by 2 is 6, remainder 0. And then 6 divided by 2 is 3, remainder 0. And then 3 divided by 2 is 1, remainder is 1. Then you take from bottom to top and the number is 11001 in binary. This one okay, no?
Yes, sir.
Right. Okay, then let's go to octal. 25 divided by 8. It is 25, you have 3. Remainder is 1. Then no need, you can't divide this again because all digits are now already in octal. Take from bottom to top. Bottom to top means first go from right to left. Sorry, left to right, left to right and top. Left to right and top. Left to right and top. Then you will get 3, 1 is the value. That is octal. Okay, then
Uh,
25 divided by 16. You have only 1 and remainder
right.
is 9. Then again do the same. So 1
Yeah.
and 9 both are belongs to hexadecimal. So you write like 1 9 in 16 and that is the hexadecimal. Easy,
Oh, okay.
right? So because both 1
Yeah.
and 9 belongs to hexadecimal, 3 and 1 belongs to octal. That's why I said even you discuss octal or not, even in octal is not they are in your syllabus or not, doesn't matter. So I just want you to practice the
Okay.
method only, right?
Right.
Okay. So now can you do the next one?
Right.
Okay. I think do you need time to write down this or this is okay, no?
Uh, I'll take a screenshot.
Yeah. And here binary one, actually you have a mechanism to find out whether your answer is correct. If this number is odd, 25 is odd number, no?
Yeah.
Then this will be 1. If this is even, this will be 0. If this is even, this is 0. If this is odd, this is 1. So by that, by checking the odd even status, you can verify the answer. If this is, for an example,
Mm.
if this is odd, you got 0, means something wrong,
Right.
right? Likewise, you can verify if it is odd, it should be 1. Yeah, odd, it should be 1. That is for binary, but for other two, you don't have such.
So there's also another method where we would to take that 2 to the power of 0, 1, 2, 3, that table, and then we'd find how much it'll add up and then put ones in that place.
Hmm?
Like there would be a table, 2 to the power of 0, to the power of 1, to the power of 2,
Yeah.
to the power of 3. And
Hmm.
then that would be equal to 1,
Ah, yeah,
2,
yeah, yeah. You can add
4,
and
8,
yes, you
and that.
can add and find
Yeah.
out. That is also correct. So here you have yes 2 to the power 1, then add up. This is like 2 to the power. For an example, that's the other way. You just think in other way. The reverse conversion. Reverse conversion means this is 1. 1 plus this is 8. 1 plus 8 is 9. 9 plus 16 is yes 9 plus 16 is 25. That is the method. So that one.
Yeah.
Yeah, you have table of 2 to the powers, then you add then find out what perform, that means what forms 25. So which combination forms 25, right? So you can just start from
Right.
1 lower than 25. 1 lower than 25 means the number it is 16. 2 to the power, which one lower than, for an example, you have all these 2 to the power numbers. So let's write down like this. You have 1, 2, 4, 8, 16, 32, 64, 128, 256.
Yeah.
So when someone asks, okay, find out what is the value of, let's say, 67, you go and check with this and you will start with this here. 67, 64 is one, 64 is the one closer to 67 and less than, closer and less than, that is
Yeah.
64. 64 plus you need 3, 64 3
Two
3,
and one.
which is close and less than is 2. So you have 64, then remainder is 3, you need 3 to find out 3. So then you can go here and yes, 2. 2 is the less than, and 1 to 3, then 2. Then you need 1. 1 is this one. Then 64 plus 2 plus 1. Then you write like this. So this should be other way actually.
Right.
Yes, 1 0 0 1 0 0 0 0 1 1 1 0
Mm-hmm.
0 this way. 1 0 0 0 0 1 1. So that is also correct. That's why I said that there are enough number of methods to do that. That is also correct.
Right.
But the standard one for applicable for all the number system is divide in by base and write the remaining. Right? Okay. Let's quickly calculate
Yeah.
this. Yeah, let's quickly calculate these three. I'll give you again 10 minutes to calculate these three. So quickly do that and then discuss, because I have to give you the short method as well. There's a short way to do that. I have to explain that as well. Okay, 513.
Oh, okay.
513, I'm going to divide this 513. Sometimes in the book you can do in this way, right? So 513 and then write the remainder. So this is 256 and remainder 1. Okay, so let's put dash and write the remainder. So then, so this is 128 and remainder 0. Then you have 64, remainder 0, 32, remainder 0, then 16, remainder 0, then you have 8, remainder 0, 4, remainder 0, 2, remainder 0, and 2 divided by 2 is 1, remainder 0. So this is some another method. So why I just gave this, because sometimes you have learned this method, that dividing you write down this method, divide and then divide by 2 and write the remainder, divide by 2, again divide by 2 and write the remainder, divide by 2 and write the remainder, divide by 2 and write the remainder. So likewise you can repeat.
Right.
Sometimes you have learned this method as well. 513. So what is the answer basically?
1 0 0 0 0 0 0 1.
Yeah. So how many zeros? 1.
1 2 3 4 7.
Should be 8, no? 1,
Yeah,
2,
8, sir.
3, 4. Yeah, should be 8. 1, because this one also you have to write. 2 divided by 2 is 1 remainder 0. This 0, some students forget. 2 divided by 2, they write 1. But they will not write this one. 2 divided by 2 is 1. But you have to write 1 remainder 0. Then only you will get the correct answer. Because the other method that you have said. So what is the other method that you have said? You said that 513 can be calculated by 512 plus 1.
Right.
512 plus 1. 512 plus 1 method is that. So in this 512 plus 1 method, so this is 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. So then you can see this is 512 and this is 1. So that is also correct.
Right.
So, but if you miss this 0, it will give wrong answer. If you miss this 0, it will give wrong answer. Right? Understood?
Right. Yes,
Okay,
sir.
then octal. Then octal. So let's write in octal. Use the same method. Then use table. So you have to divide by 8. The value is 513. 513. And write the remainder, divide by 8. 513 divided by 8 is, so what is the value? 513 divided by 8, 64. And remainder 1. Then again divide by 8. 64 divided by 8 is, what is the value? 8. Remainder 0.
8,
Then 8 divided by 8 is 1, remainder 0.
0, and
So
then
yeah,
1.
let's remove borders in this section. Border style. Okay, now let's go to home. Remove all the borders. No borders. And here also bottom border. Sorry, top border. Bottom border only, and the left border. So this one you don't have borders. Okay, now you can see the answer. That's why I just done that.
Right.
Okay, so this is the traditional method. So 513 divided in 64, remainder 1, 8 remainder 0, and 126. So the answer is 1 0 0 1 in octal.
Yeah.
Okay. Then the hexadecimal one. So you can use the same method. Copy this and just divide by 16 this time. 16, when you divide, the answer will be 32. 32 remainder is 1. Then again divide by 16. Then 16, this is 2. Yeah, so no need to divide again because then all the digits are converted. This is 2 remainder 0. So answer will be 201 in hexa.
Right.
Correct?
Yes, sir.
You got these answers?
I got, yes, sir.
Yeah, you got. Okay, so integer one, I think it's easy, and I'll give you the short method as well. Short method I'll teach you in a while. So before that, let's convert these other two also. So 1024.8, yes, 1024.875. This part you are okay, no? 1024.
Yes, sir.
Right, it is, let me write the answer because I'm not going to write this, actually calculate this again because you already know this, how to do that. So, but if you have one answer, please tell me, then I can calculate and show you. It is 1 and 10 zeros.
Yes.
Then you need answer for 875, here 10 zeros. 0, 5 zeros. So this is easy in your method, no? Second one, why? 1024 is, you know, it is 2 to the power 10. 1024 is 2 to the power 10.
Yeah.
2 to the power 10 means 1 and 10 zeros. So these numbers easy, right? If you have like
Yeah.
8 means 2 to the power. So what is the value? 8 means 2 to the power 3. So for an example, 2 means 2 to the power 1. Then you write 1 0. Then
Right.
4 means 2 to the power 2, 1 0 0. 8 means 2 to the power 3, 1 0 0 0. 16 means 2 to the power. Yes, tell me. 16 is 2 to the power 4.
Right. Right.
Right? 32.
Yes.
2 to the power 5.
The-
Then 5 zeros.
Right.
64.
64.
64 is then 6 zeros.
2 to the power 5.
2 to the power 6. 6
Oh,
zeros.
right. My bad.
Yeah. 2 to the power 6. 6 zeros. So 1, 2, 3, 4, 5, 6. 6 zeros. Then 128. 2 to the power 7. 1,
Oh, 7.
7 zeros. Then 2, 5, 6. These numbers, these 2, 5, 6. Then 1, 8 zeros. 5, 12. 1, 9 zeros. Then 1024. 2 to the power 10. 1 and 10 zeros.
Right.
So it's easy to write these numbers. And as well as it's easy to write these numbers. 1. 1 is 1 in binary. No, 1 is
Yeah.
1 in binary. 3. 3.
101.
3 is 1 less than 4. You write like 1 1. 3
Uh,
divided. So here you had 3. Here. You had 3. 3 divided by 2 is 1 remainder 1. It's 1 1.
yeah.
Then what about 7? 7. 1 less than 8.
Mm,
So identify the pattern.
mhm.
2 is 1 less than 2. It is 1. 4 is 1 less than, sorry,
So
3 is 1 less than
101.
1 1. Here 7 is, should be 1 less than 8. 1 less than 8 means 1 1 1. Identify the pattern. Here this is 1 less than 2, 1. 4 is 1 less than, sorry, 3 is 1 less than 4. It's 1 1. 7 is 1 less than 8. It is 1 1 1. Then what is 15? 1 less than 16.
Yeah.
What is the value? Find the pattern.
Mm,
1 1 1 1 1 1 and 15 is
yeah. I
1 1 1 1. So what about 31?
111.
That is 31. So
Okay.
63?
Will be 16 plus.
63 is 1 less than 64. 64 you had how many zeros?
111.
64 you had 6 zeros. Here.
Yeah.
Then here 6 ones. Okay, let's go here. 1023. How many ones? 1024 is 1 and 10 zeros. Then 1023
Yeah.
is 1024 is 1 and 10 zeros. Then 1023 is 10 ones.
1 and
Understood? It's like this.
yeah.
In 10 to the power, you have 100. 1 less than 100 is 99. Right? Okay.
Right.
Let's say you have this value in some number. 1 less than that number is 9999999. So all the zeros
Mhm.
will be converted to next immediate digit. That is 9. All these zeros. How many zeros? 1, 2, 3, 4, 5, 6, 7. 7 zeros means 7 nines. This is 10, base 10.
Right.
Similar to that in base 2. So 1 less than the particular number is all zeros will be converted to the most significant digit, which is ones in the particular power base. So these are easy ways to find out. Quickly guess the number, that is easy way. Maybe MCQs, you can use this kind of short method to find out the value. Okay, so that is additional thing.
Yeah.
So that is additional thing. Okay, 1024, you know, this is the value.
Yeah. Hello.
Hello,
Yes, sir.
right. Then point 875, 0.875, 0.875 means 875. This is 0.875. What is the method? So you have to multiply this 0.875. Okay, let's go here. Just few enters. 0.875 multiplied by 2. What's the value? This is where you are struggling. So what is the value?
Yeah. 1.75.
1.75. Then what is the next step? You have to take this 0.75. 0.75 and multiply by 2. Then what is the value? 0.75 only, yeah? Only the point part. 0.75 only. Then multiply by 2. Sorry. Multiply by 2. What is the value? 0.75 into 2.
3.5.
You are multiplying the whole thing. 1 point, not 1.75. Okay. Don't take this one. One is now out. Don't take this one.
Oh,
Don't
okay.
take this one. So I'm highlighting it.
So 1.5.
Right. I'm highlighting is yellow color. Now we have found one. Now we are not going to take that one. Only take the green color area. Only take this green color area and multiply. Then you know value is 1.5. Again the same thing. This yellow color
Right.
area you don't take. This yellow color area, don't take this one. So take only the green color area. So what is the value? 0.5 into 2. 0.5 into 2.
1.
1. So 1.0 basically. When you get 0, you have to stop this and take from top to bottom. Top to bottom means take from here to here. Okay, then what is the value? It is 1 1 1 1 1 0. If you want, you can take 0 as well. But anyway, 1 1 1. That is enough. This is the answer. This is the answer.
Right.
Okay, similar to that in Octal, right? In Octal also you can use the 1024. So I'm going to use the same method. Now this is 1024. 1024.875. Let's forget about 875 first. 1024 divided by 8. What is the value? It is 128. Remainder is 0. 128 divided by 8. What is the value? 1. And here
16.
16. 16 remainder 0. 16 divided by it is 2 remainder 0. Then what is the value? 2 0 zeros you have to take from. So what is the direction? So first you have to go from here to here. That is the direction. Then the value is 2. Sorry. Then the value is 2000 in octal. So, but that is the integer part. That is the integer part. You have to think about the fractional or the decimal part as well. In decimal part, you have 0.875.
Right.
0.875 into 8. What is the value? 0.875 into 8.
7.
7. Correct. Yeah. 7.0.
Yes.
Yes, 7.0. Now, since this is 0, you are going to stop from this level, because after that, everything will be 0. You take from top to bottom. Take from top to bottom this way. Now you have this 7 only. So what is the answer? 2000.7 is the answer. Understood?
Right.
Right.
Yes, sir.
In hexadecimal, again, you are going to apply the same mechanism. Hexadecimal, but this is 16 now. 16. You divide 1024 by 16 will be 64, and remainder is 0. 64 divided by 16 is 64 divided by 16 is 4, no? 16, 16, 32. Yeah, 4. 4 remainder 0, and you don't have this part. Okay, then 400. Then 400. The value is 400 in hexadecimal. So what you're going to do after finding this value 400 in hexadecimal, what's next? So find out the decimal point 0.875, 0.875. So what you have to do is multiply that by 16. Multiply by 16. So what is the value? It is
Right.
14, 14.0. And since it is 0, you are going to take from top to bottom and stop. 14 has value. What is the value? 14 is point E, no?
Mm.
14 has a value. If it is 15,
Yeah.
it is F. Yeah, if it is 15, it is F. Since 14 is E. 14 is E. So it is 400 point E. Now, is it easy or difficult? Is it okay?
It's okay.
Right. So let's go to the short
So
method.
in the exam there is no calculator, right?
Sorry?
In the exam there is no calculator, right?
Yeah,
You
no
can't
calculator.
use
You have to divide manually, basically. Because this
right.
part you will not be allowed to use calculator, then you don't know the method, no? Right? So maybe in other sections they might, but I'm not sure. But no calculator for this, right?
Right.
So you can just go through the question paper. Sorry, not question paper. Actually, sample questions are there in the end of the chapter. But I'll explain that part as well. There are sample questions in the end of the chapter. I'll explain that part, right?
Right.
Okay. And I mean, same time I'll go and explain a paper later. Right. Then, so this is the easy method. Okay, first we have to learn easy method as well. So we are going to prepare a table, right? For octal table is like table looks like this. Octal table looks like this. You have four. Let me reduce the size. This. Let me reduce the size. Okay, let's write this. And the first octal, what is the first octal digit? First octal digit, what is that? 0, no? So any number system, start from 0. What is the last? What is the last? Last octal digit? Siddhas, can you hear me?
Hello?
Can you hear me?
Hello, sir. Yes, sir.
Right. What is the last octal digit? First octal digit is 0,
8.
8 or 7. In decimal, you have up to 9. In octal, you have up to 7.
Oh,
Hexadecimal, it's 15. Binary, it's 1, no?
right.
So this should be 7.
Yeah.
So here, let me write 0, 1, 2, 3, 4, 5, 6, and 7. 7 is the last. Okay, you are
Right.
going to write down the digit value in front of that, the binary value. What is the binary value of 0? 0 is anyway 0, no?
0.
So what is the value of
Yeah.
2? 2, you know. What is the value of 2? 1
Uh,
is 1.
0, 1, 0.
0, 1, 0 is 2. What is 3?
1.
0, 1, 1.
0, 1, 1.
Okay. So when you write like this, you can see a pattern, clear pattern here. 0, 1, 0, 1. Let me write 4 is 1, 0, 0. 1, 0, 0. 5 is 1, 0, 1. You have to divide, huh? So 5 divided by
Yeah.
2 is 2 remainder 1. Then 2 divided by 2 is 1 remainder 0. That is 1, 0, 1. 6 means 6.
Mm, 1, 1, 0.
1, 1, 0. Yeah.
I mean, 1, 1, 1.
6 is 1, 1, 0. 6 is even. 6 is 1, 1, 0.
Oh, sorry. Oh, yeah, 1, 1.
7 is 1, 1, 1. Okay, but after writing also you can see the pattern here. 0. Can you see the toggling pattern? 0, 1, 0, 1, 0, 1, 0, 1. It's toggling, no? 0,
Yeah.
1, 0, 1, 0, 1. In logic gate also, we will discuss logic gate, that part also. So you will need this. That's why I said, even you said that octal is not there. But what will happen if you have 3 inputs in octal? Sorry, 3 inputs in logic gates. You have to write this truth table.
Right.
In truth table, you have to write this one. That's why I said, so don't think about number system, think about the mechanism, way, right? This is 0, 1,
Yeah.
0, toggling. Then the second digit, what's the change? It is 00, 11, 00, 11. See the pattern?
Right. Yes.
What will happen after the third digit? It is 4 zeros,
It's all 0, 0, and then 1, 1, 1.
right? Okay. Then if I had okay, let's say if I had 4 inputs, I'm going to write a similar kind of table. Let's copy the table and paste again, and I'm going to add this time I'm going to add a new row. Inside I'm going to add, sorry, new, not new columns to write. Over here I'm going to, okay, let's this, and I'm going to add one to left. Okay, so in numbers you can add beginning zeros, no? That will not change the value.
Right.
So beginning zeros for integers, it's not change the value. Okay, now let me increase the digits. Increase the digits. Let's draw this from the beginning. Next page, new page. Yeah, 7. In hexadecimal, how many digits? Hexadecimal, how many digits? 16 digits. In hexadecimal, 16 digits. Tell me the value. 8, 9, then 8, 9, then A,
A,
B,
B, C,
C,
E.
E, and F. And the last one is F. Can you repeat the pattern? This is 0, 1, 0, 1, 0, 1, 0, 1. Here, 0, 1, 0, 1, 0, 1, 0, 1. Double zero, double one, double zero, double one, double zero again, double one again, double zero again, double one again. This one, 4 zeros, 4 ones.
Yeah.
This one, what should be this one? 8 zeros?
8 ones.
8 zeros, 8 ones. Okay. Now, if you know these numbers, if you know these two tables, this side you have hexadecimal digits. Let me highlight this. You have hexadecimal digits. So this side you have octal digits. The white color one represent the binary digits. White color one represent the binary digits. So, okay, let's say you got a binary like this. Let's say you got a binary like this. Let's go to the question number 1, 25. Okay, let's go to this one, 25. This is the binary number that you got. I'll forward this one to you. Huh? I'll forward this note to you. This is the binary one you got. Okay, then, so let's divide into groups of 8. So groups of 3. So I can add begin in 0. And now I have 2 groups. This is set of 3. This is again set of 3. So then what is 0, 0, 1? 0, 0, 1 in this table. What is 0, 0, 1? 0, 0, 1 is 1, no?
Right.
Right. It is 1. I'm going to write this set 0, 0, 1. Let's color it in some color, maybe this color. It is 1. Same color. Okay, then this set, the second set. What is the value of that second set? 0, 1, 1. What is the value from first table? 0, 1, 1. It is
3.
0, 1, 1. It is 3. Okay, it is 3. So let's highlight in green color. 31. Can you remember the octal answer we got here? This one. 25. Octal was 31, no?
Right.
Octal was 31. So here, so if you group this 3 by 3, you can get octal number. So this is the short method. I said that I will teach you a short method. So if you get the binary, you got the binary. Then group it 3 by 3 and refer to this table. Group it 3 by 3 and refer to this table. And you will get octal. So let's write the same binary again. Same binary again. Let's group this 4 by 4. Let's group this. Let's remove all the highlights. And let's group this 4 by 4. This 4 I'm going to take in one single color. And the next 4 means how to get the next 4. You don't have 4, then to where you are going to add zeros? Beginning, no end.
To the beginning.
Yes, to the beginning. So then this is the next 4. Can you tell me 1001? What is the value? 1001. Refer the table and tell me the value. 1001 means?
9.
It is 9. 1001 is 9. And let's highlight in this color. Then 0001. What is the value? 0001.
1.
1 is 1. 0001 is 1. Then this is hexadecimal answer. Take 4 by 4, you will get the hexadecimal. Okay, see, we got 31 in 31 in octal, 19 in hexa. 31 in octal, 19. That's why I said, so first learn the method. There are enough shortcuts. So, but when you learn the appropriate proper method, then know the shortcut. Otherwise, you will know the shortcut only. Right? But know the actual method and shortcut both. Then you can find out whether you can verify your answer. You can verify your answer when someone asks to calculate and show the steps. You can calculate and show the steps, and finally you can verify it by using this table. Or if it is MCQ question, if it is MCQ like question where you need to give the answer only, you can use the short method and write down this table. So in your examination, when you receive a piece, maybe when first of all they will distribute some rough papers, no?
Right.
So in the exam, basically they are giving rough papers, no? Not the answers. The rough papers that you can do various calculations and all. But in rough papers, what you can do is you can draw these two tables. This is very useful. Octal table and hexadecimal table. These are very useful. Why? Because you can easily find the answer. Okay. Let's try for some other. Okay, this one. Okay, this one. Can you tell me the answers? What is the octal value of this one? What is the octal value? You have to take tree by tree. I'm going to separate this tree, 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 and add 0 to beginning, then tree. Here decimal part also tree. You have tree. Now can you tell me the value by referring to the table? 0, 1, 0. What is the value? You cannot see the table.
2.
Okay, no need to see. Then okay, 2, 0, 0, 0.
0.
Again 0, 0, 0.
0.
Again 0, 0, 0.
0.
0. Again 1, 1, 1. After this
7.
7. This is in octal. Can you tell me the hexadecimal answer? Take 4 by 4. Same one, take 4 by 4. When you're taking 4 by 4, so let's, okay, this one 4, again 4 from this one, 4 from this one. What about the decimal one? You can add 0 to the end. It will not
Right.
change the value. You can add 0 to the end. Now tell me the answer.
Mm. So in the middle, it should be the one more 0, right?
Which one?
The middle of this, there's only 3 zeros.
Oh, yes. This is 0, 4 zeros. Correct. Okay, now you can tell.
Yeah.
This is beginning 0. 0, 1, 0, 0.
4.
All zeros 4. All zeros 0.
0.
Then 1, 1, 1, 0.
E.
That is in hexadecimal. Easy, no?
Yes.
So that's why I said, so learn the hard method, then learn the easy method, then you feel that easy.
Right.
But don't forget the original method. Don't forget the original method. That is also required. So this is the short 2000.7, 400 E. Let's say go here. 2000.7, 400 E. So you can see same answer. Okay. So you need time to draw this, no? Write this.
Yeah.
Okay. So can you see the screen or too small?
I can see the screen.
You can read, no? Right. Okay, let me explain how we have done that. And actually, the first one, so I have explained this example. Using this example, we will start from 2 to the power 0, 1, 2, 3, 4, 5. Likewise, we will update. So starting from 2 to the power 0 into 0, the green color one, 1 into 1, because you have 1 here. Then remaining 3, 2 to the power 2 and 2 to the power 3 and 4, all are 0. And then 2 to the power 5 is 1. So let me use the same method, and I'm going to write this one. Okay, this question, so you can say I'm going to write these things in only 1 plus, you don't have 2's, you have 4 plus, here 8 you don't have, 16 you have 1. Then no 32s, but 64 you have 1. 64 1. Then no 128, no 256, 512 you have 1. So the total value will be, yes, here 16 plus this is what is the answer you get? You got this one. What is the decimal value?
I got 597.
597. Okay, let's say this is 16, 64 plus 16 is 80. 80 plus this one is 592, and 592 plus 5 is 597. Yes, correct. 597 in decimal. So the next one, how we are going to convert that to octal? So take this tree, and this tree again, and this is 1125. Correct? Yes, 5,
Yes.
1, 1, 1, 1, 2, 5. And in octal, you have to take like 4 by 4, and then the answer will be 552. It is 255 in hexadecimal. Correct or wrong?
Right.
Right. Okay. So then the next one.
Yes, sir. That's what I got.
Okay. Next one. Let's do quickly. So here you have, okay, similar to that, no ones, no twos. 4 you have 1. 8 no. 16 no. 32 1. 32 1 here 4 plus no 8 no 16 32. 36 point. Here you have 7.5. 0.5 and 0.25 is 0.75. 75 no, here 0.125 no, 0.625. So altogether you have to add, I'm going to add this decimal 1 plus 0.5 plus 0.25 plus 125 you don't have, but you have 0.0625. So altogether it is 0.75 plus 0.625 is here you have 75 plus 0.625 will be 5 to 6 plus 5 is 6 plus 5 is 11, remained 1, then 8125. So the answer is 36.8125. Correct or wrong?
I got 36.14.
36.14.
14. Yeah.
How? This is decimal. In decimal, what you have to do? In decimal, you have to add these things. What is the positional value of this digit? Positional value of this digit is, let me write down. What is the positional value of this digit? It is 2 to the power minus 1.
Yeah.
Right. What is the positional value of this one?
2 to the power minus 2.
Minus 2. Yes, 2 to the power minus 2. The next one?
2 to the power
Minus
minus 3.
3, and this one is minus 4. And then 2 to the power minus 4. You have to add, no, you don't have 2 to the power minus 3 because it is 0, no? Anyway, you have to add these 3. This one plus this one plus this one. So you have to add these things
Oh.
because you don't have 2 to the power minus 3. So let me, 2 to the power minus 1 divided by 2 plus. So minus 2 means 1 divided by 4 plus minus 4 means 1 divided by 16. Altogether value is here 8 4. So let's put all into 16. 1 divided by sorry, this is then 8 divided by 16 same base. So then here you have 4 divided by 16, and here you have 1 divided by 16. So altogether you will get 8 plus 4, 12, 12, 13. 13 divided by 16. And what is the answer if you divide 13 divide by 16? Should be 0 0.13. You don't have, but 1 3 1 3 130 130 වලට තියෙනවා 8ක් තියෙනවා 128 වලට තියෙනවා. You have 8,
Right.
right? You have 8. So because 128 remainder is 220 wala 20 you have 1, 20 you have 1, then again 4 is remainder, 40 you have 2, 8 remaining, 80 you have 5. So it is 0.8125. So 36.8125 is the answer. Okay, I think you have
Yes, sir.
calculation error there, right? Okay, so but it's easy to convert the octal and hexadecimal. Octal is simply octal is this is 4, this is 4, it is 4 point, and this one is 6, 4.6, and you can add 2 zeros here to make it 8. 4.64, 4.64 is the octal one. And what is the hexadecimal one? Hexadecimal one is here you have 4, then you can write 24 point, sorry, 24 point, this one is 1101 means 13, 1101 1100 1101 is in the table, you know, 1101 1101 is this one, D. This part correct, hexadecimal and octal part. Hexadecimal and octal you got correctly.
I got 24B.
This one no. 4.64.
No, I got 4.64, but I got for the third one 24B.
B. So why is that? This is 1101 no.
I think I took it wrong from the table.
1101 no. 1101 in the table here. 1101 is the this one. I think you got you referred wrong figure. I think maybe.
Yeah.
Right then. Then the next one. Next one. Let's add this. Okay, sorry. How many ones? How many ones? How many ones? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 ones means 1 less than 9 1 means 1 less than 9 zeros, no?
Yeah.
So we all know the method. So I said this 9 ones means 1 less than this one. If you had this one, what is the value? This is 2 to the power 0. I can 1s, 2, 4, 8, 16, 32, 64, 128, 128, 256, 512. Then 1 less than this one means 511. Point. This is 875.
Right.
That is base 10. Next one. Seven. It is easy. 777.7 in octal. Hexadecimal. What was the answer you get? You got. I think it should be 1FF point.
1FF.7.
That's wrong. 1FF is correct. This is, you can't say 0.7. Why? You have to take 4. You have to take 4. In order to make this 4, you need 0. Then it
Oh, I put the 0 before.
before 0, it will change the value. I said that. So I repeat. I said in the this one, I think we have mentioned somewhere. Adding 0 to right side of the decimal will not change the value. You can add zeros right side only, this side only. You can't add
Oh,
zeros
okay.
here. No, not allowed. Cannot do that because that will change the value. You can add in 0 only. So then with that concept, it is E. Sorry.
Right.
Here. So which one? All right, here. 1FF point E. Okay, correct it. Huh?
Yes.
1FF point E. Okay, then let's do the last one. Last one, this one. I think you have to, you can increase the speed with this. So do this again and again. Try to increase the speed because that is really essential in the examination.
Right.
Right? The decimal value for this one. It is no ones, 2 you have, okay, 2. Then fours, yes. 8, no 8s. 16, yes, you have 1. 16, no 32. 32, 64, you have 1. 64, you have 1. 32s, no. 64, yes. This one. 1, 2, 4, 8, 16, 32, 64, 128, no. But 256, yes. 512, no. 1024, yes. 256 and 1024. So what's the total value? Total value will be here 80. Here 460. 260 plus 80 will be 340. 340 and 340, and this one will be 364, 366. 1366, correct?
Right.
Right. 625. Sorry. 625. Correct?
Yes, sir.
Okay. The next one, take 3 by 3. In octal, this is 6, 2, 5, 2, 2, 5, 2, 5. This is because you can put 0 here. 2, 5, 2, sorry, 2, 5, 2, 6.5 in octal. Then hexadecimal, write 4 by 4. This 4 is 6, 5. So it is 5, 5, 5, 6 point A in hexa. Got the answer?
Yes, sir.
Right here also you have to add that 0 to n in 1010, which is 8. Okay, so this is so now I think why you can understand why computers are using these hexadecimals. What's the reason? Main reason. If you use this, so you know anyway computers are using binaries.
Right.
Right, anyway computers are using binaries. Even you can see, so it is the easiest way to feed computer kind of input, because in power on button also you can see this symbol. In power on button also you can see this symbol, which is the easiest way to feed something to a digital device. It is 1 and 0. 1 0, this is power on button, basically the symbol 1 0. That is the easiest way to feed computer. Let's say the switch is there. Let's say there's a switch. So when you press 0, it will off, or when you put that off, bulb will off. If you put 1, or if you turn on the bulb, it will on. That is the easiest way to convince electronic device to turn on and off using 1 0, two symbols. That's why computers uses binaries. So it's very easy to instruct electronic devices and circuits, because
Yeah.
one means presence of electricity, zero means absence of electricity, or sometimes one means high voltage, zero means low voltage. Understood?
Yes.
Okay. So for an example, let's say you access a website. Okay. So let's go burn in ZD or DDD, burn in CD or DVD. Let's say pit and land. Okay. Can you see this image?
Yes, sir.
So you can see the pit. Pits are burned places. Okay. The
Mm.
lands, pits and lands. And other way. So here, this is the diagram. This is the diagram, and this is how it is formed. When writing, right? When writing here, this. So the burned places. Okay, this is how, right? When there's a laser bulb, basically there's a polycarbonate layer and the laser bulb. So in basically in the burning, so what really happens in the burning, it will melt. It will melt this polycarbonate. Sorry, it will melt this reflective aluminum layer. Here you can see it will melt the reflective aluminum layer. How this melting happen? Because when there's power, the laser bulb will turn on, and when you turn on the laser bulb, it will go and burn the aluminum layer. Understood how these are formed,
Yes, sir.
right? When there's a power, okay, let's say you power on the bulb. When you power on the bulb, the laser head will emit that light, and that light will go and hit this aluminum layer. This can be aluminum, platinum, or gold. But in rare cases, you can see aluminum, so platinum and gold. More common, you can see aluminum CDs, aluminum plated CDs. Anyway, when reading happens, there will be like this low power laser bulb based on the reflection angle. Based on the reflection angle, only the reading happens. Right? Writing, what will happen? In writing, it will go and
Right.
melt the layer. When reading, based on the reflection or the reflection angle, you can find whether that is a pit or land. This is another image. So this is actually a theoretical explanation. So when there's a land here, you can see. But when there's a pit, it will go and not come back. It's a pit, and but it will go and not come back. So O based on the angle of reflection. So here they have used angle of reflection. When there's a pit, it will reflect this way. When there's a here, when there's a land or the other, so that will not. So in physically here, when there's a pit, here difference between pit. When there's a pit, the reflection will be different. When there's a land, reflection will be different. Based on that only reading happens. Anyway, using ones and zeros, it is very easy to represent these two status, ones and zeros. That's why computer uses binaries. Understood? Hello?
Yes, sir.
Right. So, but when you write in binaries, you can see those binaries are lengthy. So here these binaries are lengthy. But when you compare, the hexadecimal is short version of this. Here, the hexadecimal can be used to shorten this. So this is lengthy binary. You have 8 bits. It's lengthy, 8 digits, 8 symbols. But here in hexadecimal, it has only two symbols. Here again, the same thing. Binary, this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But here it has only 3.
Right.
Right, here also it has only 1, 2, 3. But this is lengthy. Here also the same. This is lengthy, but this one, it's more short. Why we are not using decimals? Why we are not using decimals? So decimals are also short, no?
Yeah.
Why we are not using decimals inside computer? Yes? Decimals, it's quite kind of difficult to calculate and convert, no? Because you have to always find the positional value and add those and multiply by the digit value and add those and find the value. But this one, you can just refer to this table, and quickly calculate this one. Hexadecimal. Write 4 by 4 and shorten. In the other way also, 5 means 0, 1, 0. Again, 5 means 0, 1, 0, 1. 6 means 0, 1, 1, 0. A means 1, 0, 1, 0. So converting to binary is also easy, no? Convert into binary also, you have to write 4 by 4. This 4, this 4, next 4, and this 4. Then you will get the original binary. And from binary to hexa also, it's easy. 5, 5, 6, and A. So when you have hexadecimal like this, A0, A, B2, so binary, finding binary is very easy. A means 1, 0, 1, 0. 0 means 0, 0, 0, 0. 1 means 0, 0, 0, 1. B means 1, 0, 1, 0, 1, 0, sorry, 1, 0, 1, 1. B means. 2 means 0, 0, 1, 0. It's easy to find the binary, machine binary. Because of that conversion, yes, because of that issue, or because of that uh, easy calculations, computers are using hexadecimal and binaries. Octals, it is intermediate version. Octals not much used. That's why octal is not given in your syllabus, no. So basically, it use binaries and hexa. Understood?
Yes, sir.
But we are not going to use these binaries and hexa in our day-to-day life. We can't go to shop and tell, give me A0 kilograms of sugar, or can't tell, give me A120 kilograms of flour. Cannot tell like that. No, we are using decimals.
Yeah.
Therefore, there's a mechanism. There's a mechanism to convert from our that means our decimal number system to binary and hexadecimal. We have to learn that. That's why we are learning decimal. Decimal we use day to day life. Computers use hexadecimals, binaries, and octals in day to day life. That's the difference. Right? We have to always feed. We have to always feed things in binary to these computer systems. So even a letter, even a graphic, even a sound, it will analyze this as a binary. Even a letter, graphic, animation, video, everything should be fed in binary. So there's a mechanism to feed letters. So there's a system called BCD. That system is called binary coded decimal. In BCD, what happens in BCD? You have digits from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These digits are given binary values: 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, and 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, then 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, Likewise, for numbers, they have introduced, this is BCD system. For numbers, they have given digits. These are decimal numbers, right? These 0 to 9 are decimal numbers.
Yes.
Right? In decimal numbers, basically, so when you have decimal digit like this, okay, say for an example, think about 783, 793 in decimal. Basically, in traditional conversion, what we did, we divide by 2 and write the remainder, wrote the remainder. That is the traditional conversion. So you can remember the steps. No, we did in the beginning today. Actually, this stage we did that. We have divided by 2 and wrote the
Mm-hmm.
remainder. This was the mechanism. No, then we have to from bottom to top. Can you remember?
Yes, sir.
Right. But in BCD, we are not going to take that effort. Actually, we are going to be lazy in BCD. So BCD was introduced with these digits or these digit codes. So we are not going to divide this. Even you have decimal, we are not going to divide this. We are going to write this using this digit. 7 means this one. 9 means this one. 3 means this one. But you are not going to write 2 here, right? You are not going to write 2 here. Because BCD, you are not going to mention base even.
Mm-hmm.
When you get a number, simply you write the binary code related to that using this BCD table. Similar to how we converted from binary to
Right.
hexadecimal and hexadecimal to binary. Understood or not? This is
Yes,
special
sir.
system. Yeah, this is called special encoding system. This BCD or binary coded decimal
Mm-hmm.
is special encoding system where
Right.
so we use day to day life, we use this day to day life, we are using these decimal numbers. No, when you get a decimal number,
Mm-hmm.
computer can easily translate this without dividing by using BCD codes. 1 means 0001, 0 means 0000, 2 means 0010, and sorry, so you have to write like this one 0000, then 9 means 1001, and 8 means 1000. So you are using this easy method to convert. But this is not mathematical binary to decimal, sorry, decimal to binary. This is not mathematical decimal to binary, okay? This is called binary coded decimal representation. This is not maths. This is computing. In maths, you have to divide. But in computing, there's a easy method. In computers, use easy method called BCD, where you represent one digit by some other digits. Digit 6 will be represented using this 4 code BCD. Digit 8 will be represented using this 4 code BCD. Understood?
Yes.
Right. Okay. Then but this method you can't represent letters, no? You can't represent letters in this method because you can represent 0 to 9 only. What will happen if you
Mm-hmm.
want to, okay, let's say you want to represent Sedas. You want to tell computer your name is Sedas. Now you are going to instruct the computer in binary. How you are going to tell that?
Yeah.
In BCD, can you do this? Can you use BCD to tell that?
No.
No, BCD will support only numbers. So therefore, they have introduced some other systems. One is EBCDIC, Extended Binary Coded Decimal Interchange Code, EBCDIC. Here you can see the EBCDIC table. Can you see the EBCDIC table? So how to write letter A? I'm going to copy this EBCDIC table. Actually, this is not EBCDIC, this is extend. This can be EBCDIC, this can be extended ASCII as well. So let me show this by loading the page. Still loading. Sorry. Yes. Internet is quite slow these days, no? I think everyone is trying to learn online,
Yes,
and
sir.
that's the main reason. Because even Dialogue responded that. So one friend from Dialogue, he said that they are using like so usually it was 80% traffic, but nowadays they are getting like 120%, which is closer to 2 times than the earlier traffic.
True.
So that's why the connections are quite slow now these days. Okay, so this has long note, but I'm not going to tell that. This is okay. This is EBCDIC. IBM has introduced this EBCDIC, binary extended binary coded decimal interchange code. Okay, I'll copy this because then I can share this with you as a note. Extended binary coded decimal interchange
Right.
code. Extended binary extended BCD, binary coded decimal interchange code is EBCDIC. Here in EBCDIC, they are using both octal and hexadecimal number systems. Right? They are using both octal and hexadecimal number system. You can see by this side. So you can interchange the sides. So this side y direction you have 0 to f. X direction also you have 0 to f using hexadecimals, no? 0 to f, 0 to f. Okay, what is letter A then? How to write letter A in EBCDIC? Letter A in EBCDIC, it is this side. What is the value? C, no?
C,
Think this as Excel sheet. This
C1.
side C. This side it is here. Letter A is C1, no?
1. Yeah.
C1. No, C1. Let's say C is how they are going to write this. Okay, let's copy and paste this. And according to this EBCDIC chart, letter A is letter A. Here you have letter A. It is C. This side 1. C1. Letter A is C1 in hexadecimal. How we are going to convert this to binary? C means 1100. 1 means 0001. This is how they have used letters. Letters even they have converted to using this is EBCDIC. In EBCDIC they have used this method, and in ASCII they have used this side octal and this side hexadecimal. Right. ASCII means what do you mean by ASCII? ASCII. Have you heard of ASCII?
The codes for the letters
Yeah.
like A65.
What do you mean by ASCII? American Standard Code for Information Interchange. That is called ASCII,
Audible.
right? American Standard Code for Information Interchange. That is ASCII, and there's an extended version, extended American Standard Code for Information Interchange. That is extended version. This ASCII is 7-bit. That means 2 to the power 7 symbols. Means how many symbols altogether? 2 to the power 7 means 128. EBCDIC, BCD has 4 bits. So BCD has 4 bits. Maximum it can go for 16 symbols. 4 bits means 16 symbols. Extended ASCII 8 bits. How many symbols? Extended EBCD, EBCD or EBCD 8 bits. How many symbols altogether? 2 to the power
8.
8 symbols. 2 to the power 8 symbols should be 256 symbols maximum. It could go for 256. But all symbols are not allocated, right? You can see some symbols are blank here. These are not allocated. These are not allocated. These are not
Right.
allocated. Some are blank. But maximum, if they use maximum, they can go 16 here, 16 here, 16 into 16 means 256. But they have not used that. Extended ASCII also 8 bits. So maximum it provide extended ASCII also 8 bits. Maximum it provided 256 symbols. And there's something called Unicode. This is famous. Unicode is you have two versions. One is 16 bits. In 16 bits Unicode, how many symbols? 2 to the power 16 symbols. 2 to the power 16 means what's the value? Can you tell the decimal value? How many symbols in Unicode?
65536.
65526. 2 to the power 16 means 65526. Sorry, see, correct? Right, no?
Yes.
65526. This is the symbol. Why Unicode is introduced? Because you know that these characters, these character encoding can write English, but not Latin. No, not Latin characters. Then there were again a problem. So others also wanted code like Sinhala, Tamil. They also need some codes, no? That's why Unicode was introduced. It support
Right.
multilinguals. It support multiple languages. Unicode support multiple languages, but this ASCII, extended ASCII, Ascii, it support English only. English and numbers. English, numbers and some symbols. But when it comes to Unicode, it support English, numbers, some symbols. Not only that, some other languages. Most probably, most languages are now in Unicode. Right? Most of the languages now in Unicode. May I know what's the mother tongue that you are using, Arabic or Tamil? You are using Arabic or Tamil?
Okay.
You are using Arabic or Tamil as your mother tongue.
For
As your mother tongue, you are using Arabic.
I speak single, sir.
Are you speak Sinhala? Right. Okay. Anyway, whatever.
Yeah,
So,
yeah.
right. Then, yes. In that case, you are using that Sinhala, Tamil, Arabic, whatever. In any letter, you can write it Unicode. So that's the idea. So I have shortened the lesson because that lesson you have big note, but I have make this short one, right? So here
Mhm.
these are some ABCD control codes. Control codes means you can give can is CAN means cancel. CU2 is customer use. You can define that. Then new line is NL. Enter. New line is NL. Space is SP. So you can see these symbols. But
Right.
just read the book. In your book, there are symbols related to ABCD. I'm not going to repeat the same thing because you can go and read the book. And not only that, ASCII they have not mentioned. I'll show you ASCII table. ASCII table. Here, this one is used basically. This is unsigned ASCII, US ASCII chart. You can see this side. What is the number system? Hexadecimal, no? 0 to 15. It is
Yeah.
hexadecimal. Here's this side. 0 to 8, 7. Sorry, 0 to 7. It is octal.
Right.
Then how to calculate this? How to calculate? So tell me letter A. So what is letter A? What is the value of letter A here using ASCII? Where's letter A? Here you have letter A.
Yeah.
What is the value? You read from this side 100. From this side it is 000 1. First read the column
One.
100. This side it is 000 1. A is
Okay.
1000001. What is the decimal value? What is the decimal value? Can you convert decimal? This is 1. Then this is 2, no
Yeah.
2, 8, 16, 32. Sorry, 6, 8, 16, 32, 65, 64.
65.
Altogether it is
65.
65. Yeah, 65. So you can test this even. So if you are using computer, if you type Alt key plus in numpad, right? In numpad, if you type Alt key plus numpad means, in keyboard you have separate section called number pad. No? Keyboard you have this part, no, number pad, this section, right? Not this section, not these numbers. You can't use these numbers. When you're using a computer, so when you're using a laptop or computer, if you press Alt key, Alt key, and press 65 from this side, Alt and 65, Alt and
Mm.
65 from this side. So that will print. You can try this, okay, in your computer also. Alt plus
Mm-hmm.
65 here. Alt plus 65 is letter A. Alt plus 64 or 66, it's B. 67 C. 68 D. So here you can see 65
Mm-hmm.
A. Then 10 66. Then 11 60. Then 10 This is how you get letters. Alt plus, then you can try these symbols. Alt plus this. In order to press add, it is 64 here. Alt 64 is add mark. Add mark.
Right.
Hmm. Likewise, there are keys assigned in your keyboard. You can give it as symbols. So let's say, let's try virtual computer keyboard. I'm not sure whether it is available. Let's see. Virtual computer keyboard. Because I'm using Mac, I cannot show this to you. It has download in type language anywhere. Let's see. Okay, this one. Select your language. Let's say English. Continue. Again, it doesn't. Cannot see the number pad. Unfortunately, cannot see the number pad. That's right. Alt plus.
Right.
Hmm, I need number pad to type that. Otherwise, again, there will be a problem. Default US and no QWERTY keyboard and QWERTY default. No, not this one. I need the keyboard with number pad. Sorry. You can try this alone. You can try this alone at your home,
Mm-hmm.
using your computer. You can try this. I'll share this note with you
Right.
and in your book actually. So then it indicates so these sections. Today we have discussed about out of these topics. So let's go back to our table of content. So here, uh, information. Still we are in information representation. And in communication and internet technologies, actually, we have discussed some. This part we
Yeah.
discussed, not in binary to denary. And this is okay. This one discussed, this one, okay. International coding numbers. So these two we have to discuss. One's complement, two's complement, and sign and magnitude. But this one, BCD, we discussed. BCD, how characters are generated and all. ASCII, we have discussed. And they have given the
Yeah.
ASCII codes. This is 63 for, this is letter, simple letter A, 97. Right? In hexadecimal, it is 61. 97 in decimal. Capital A here, 41. 41 means in decimal, what is the value? Here, 60. You can see 100, it is 65. 65 in decimal. They have given that. You can just refer to that chart. And the chart I have, and Unicode. Unicode is to give unique codes, and there are two versions. One is here. First, you can see first 120 characters in Unicode are ASCII codes. And first 128 characters in Unicode are ASCII codes, same ASCII codes. Still, we are using ASCII. And images.
Right.
Okay, I'll discuss image part and quickly discuss image part and finish this section. Right, let's take a new one. Let's take a new one. And let me quickly convert this Excel sheet. I'm going to change the height, column width to 3, and row height to 22. Right. Okay, let me do small thing. I'm going to write a binary matrix. I think you know about matrices, no? Matrices have you learned in maths?
Mm, I think so, yeah.
Yeah, this is matrix, not the film, okay? Matrix in mathematics.
Yeah.
In mathematics. Matrix in mathematics. You can see these are the matrices, right?
Yeah.
This matrix. This is also
Oh,
matrix.
yeah.
I'm going to write this as a matrix. Mathematical matrix of 1 zeros. 0, 0, 0, 0, 0, 0. Then let me write 0, 0, 1, 1, 0, 0. Then 0, 0, 1 here. 1 here. And 0 here. 0, 0, 0, 0. Then 1 here and 1 here also. 0, 0. 1 here. So this is matrix actually. I'm going to write matrix in binary. And then,
Okay.
okay, think these ones. Think about these ones. So think these ones as bulbs. Okay, think these ones as bulbs. So if this bulb is turned off, signal is 0. If this bulb is turned on, signal is 1. Okay, then I'm going to color this. Let's say bulb color is red. I'm going to color this turn on bulbs in red color. Red color. This is also red color. These are also in red color. Ultimately, what you can see here, colored one. Ultimately, what you can see, it is.
One.
It is here. It is 1. So if I minimize or if you reduce the size, you can see in my screen, it is 1. This is how letters are created in your monitor. Actually, these matrix elements, this element is called pixel. The smallest
Right.
element is called pixel. Using pixels, by changing values of these pixels, so it will create colors. Change in values of these pixels, it will create colors. And that's why we can see letters, graphics in or graphics, arts, letters, drawings in our screen. It is ultimately used in matrix. Okay, it is
Right.
ultimately used in matrix. So in matrix, you will learn if there's a t matrix called T, you can write 1 divided by T. What is 1 divided by T? If there's a matrix called T, if this is matrix T, what is 1 divided by T? Can you remember the matrix operations? 1 divided by
Mhm.
T. In 1 divided by T, what you're going to do is, if you are going to write 1 divided by T, you are going to write this side or X side in Y direction. That means here you have 3 zeros, 1, 2 zeros. You write in this direction, 3 zeros, 1, 2 zeros. Again, this one, 2 zeros, 2 ones, 2 zeros. 2 zeros, 2 ones, 2 zeros. The next one, 0, here 1, then you have 0, again 1, again you have 2 zeros. Likewise, you are going to write these things. 0, 0, 0, 1, 0, 0. Again, 0, 0, 0, 1, 0, 0. Again, next one also the same. 0, 0, 0, 1, 0, 0. And the last one, 0, not last one, 1, 1, 1, 1, 1. And the next one is 0, 0, 0, 0, 0. This is 1 divided by t. The same matrix, mathematically, you can write this way. What's really happening when you write like this? It will rotate the number. It will rotate the number anti-clockwise 90 degrees. So this is called rotation. Understood?
Yes.
So everything happened mathematically using these dots or these pixels using matrix operations. If you multiply by this matrix by 2, if you multiply the matrix by 2, what will happen? All ones will become 2 now. All ones will become 2 now. Because zeros will never, so if you multiply 0, still you will get 0 now. But if you multiply this matrix by 2, all ones will become 2. Then the values in this has changed now. 2 is actually another color. 2 is basically
Right.
another color in the string. Understood how colors are created and colors are changed?
Yes, sir.
Yes, 2 is another color. So what you have done here, you had matrix T, then you have converted that to matrix T. Actually, you have converted to matrix T. You have converted the particular matrix to 1 divided by T. And then what you have done? You have taken 1 divided by T and then you have multiplied it by 2. Means you have rotated the image and changed the color.
Right.
That's how we understand. But computer will understand this. You have taken the transpose matrix. You have taken the transpose matrix and multiply by a constant. Take the transpose matrix and multiply by a constant. Then you will get rotated 1. But how we see, we just see it is rotated 90 degrees and change the color. But in
Right.
computer, actually, it is a calculation. That's what you have to learn in the image section. So in here, representing images, right? In bitmaps and vector graphic, they have not actually given the theory, underlying theory, but they have explained how bits and all these are created. And so it is not deep one, just surface. So there are two kind of graphics. One is mathematical graphic. The second one is the pixel based, this element based graphics called bitmaps. Mathematical graphics we will learn in maybe in future. We can learn. So this is
Mm-hmm.
what is mathematical graphic? Mathematical graphic means graphic like this. So what is this? Can you remember the screen? What is this one? This is Python. You said you have Python in your syllabus, no?
Yeah.
Let me write small Python code, import turtle. Then let's say t equal turtle dot turtle. Turtle is basically for drawing. Then I'll write t dot forward. I'm going to forward this 100 or 200 pixels. Then I'm going to turn left side 120 degrees. And I'm going to repeat this. This is called a vector. Vector means I wrote a code, it does mathematical calculation, going 200 pixel forward, then turn in 120 degrees. So which will ultimately create, so see my screen. which will ultimately create this one. That is a triangle. But that is not pixel based. I have not created any matrix. I have not created any matrix. Without creating a matrix, what I did, I wrote a program, or I instruct the computer to mathematically manipulate the cursor, mathematically send the cursor and process that. So this is going
Right.
forward 200 and turn 120. Forward 200, turn 120. Go 200, turn 120 degrees. The internal angle will be 60 because you know 100 and here line will have 180 degrees minus 120 will be 60. That is the internal angle of this triangle.
Right.
Right? Just understand the concept.
Yeah.
You can try this. After I'll
Yeah.
set the recording and share it to you. You can try this. Even in your mobile phone, you can try this because you a mobile phone you have Python. You can install PyDroid,
Yeah.
PYDROID, PyDroid.
I have it. So.
You have Python. Then you can
Yeah.
try. Okay, with that I'll stop for today. Right?
Mm-hmm.
I'll share this note. I'll share this note and I'll send it WhatsApp. And also I'll share the video recordings with you. Okay.
Right. So.
Right. If you have any doubts, please let me know. Otherwise, we will finish for today.